Okay, in this question, a doctor treating a patient issues a prescription for antibiotics and provides for 2 repeat prescriptions. Okay, the probability that the infection will be cleared by the first prescription is zero point 0.6. The probability that the successive treatments are successful, given that the previous prescriptions were not successful, are P2 equals zero point 0.5 and P3 equals zero point 0.4 respectively. So calculate the probability that the patient is still infected after the third prescription, that the patient was cured specifically by the second prescription, and given the the patient is cured by the second prescription, given that the patient is eventually cured. Okay, so that's a sort of slightly different question, 2 as opposed to 3. Okay, so it actually is based on conditional probability, just in case you're wondering why that one is a little bit different. So I just hold it up to the camera again there, so you could just take a little screenshot there if you want. Okay, so what we're going to do here is we are going to use probability trees. Okay, so I just readjust myself here a bit. Okay, so what I'm going to do here is use a probability tree approach. So essentially what I'm going to do is to sort of start out here. Okay, so this is prescription 1. Okay, now P1 and so essentially what happens here is that if this treatment is successful, the first treatment is successful, the patient is cured. Okay, so this is the sort of the patient is cured on the first attempt. Okay, so on the other hand, if the first prescription is not successful, we're on this track here. Okay, and then we're going to prescription 2. Okay, and the same sort of idea. So again, it's a success or it's a failure. And then finally, prescription 3, which is here, P3, fail and success. Okay. So we have 4 possible outcomes. So, and I just marked them all there with those sort of stars there. Okay. So this is the patient is successfully treated after the first prescription. Okay, and we know that the probability of success of the first prescription is 0.6. Okay, now that means that the probability of failure from the first prescription is 0.4. Okay, so the probability of success for the second prescription is 0.5. That means the probability of the failure from the second prescription is also 0.5. The probability of a successful outcome from prescription 3 is 0.4, and then that means that prescription 3 is not successful. The probability of that is 0.6. So essentially we have our tree all together. Okay, and we got 4 possible outcomes. Successful after prescription 1, successful after prescription 2, successful after prescription 3, and successful or not successful at all. Okay, after the entire round of treatments. Okay, now the probability of this is 0.6. That's fairly straightforward to derive. Okay, so what's the probability of this outcome here? Okay, now this is how probability trees work. Essentially what we're going to do here is, starting off at the origin or the root node, we're going to calculate the distance in terms of probabilities. Okay, which is to sort of say we're going to multiply this probability by this probability. So 0.4 by 0.5 equals 0.2. Okay, this one here is 0.4 times 0.5 times 0.4. That is equal to 0.08. 0.4, 0.4, actually I say 0.4, I should say 0.4, 0.6 and so on. We say that a lot in Ireland and England, but we shouldn't, because I think other people in other countries don't recognise naught. So I should say 0.6, 0.2, 0.08, and 0.12. Okay, so just actually my little vernacular, just in case you're wondering, the word I used, it's not, which is equal to 0. Okay. Anyway, sorry about that. So anyway, we have all our answers. Okay. So the question, the first question is, still infected after the third prescription? Okay, that's the first question. Well, the answer to that one there is 0.12. 0.12. Okay. Now, is the patient is cured by the second prescription? Okay. So there we have it there, 0.2. Okay. And in fact, we got all of the possible outcomes there. So there's 4 possible outcomes. So they're very easy to pick out, just in case you were asked something else. And given that the patient is cured by the second prescription, given that the patient is cured. Okay. So what we're asked for here is essentially a conditional probability. Okay. So probability of P2 and cured over the probability, given the probability of being cured. Okay. Sorry, that is the probability of P2 given that you were cured. Now, just to be clear, P2 here means prescription 2 is what it was used to cure you. I just slightly amended the notation there. Okay, so P2 is an event here, also as well as the probability of that said event. Okay, now P2 is cured and cured. So essentially, this is how we would adjust it. So it's essentially the probability of being P2 and cured is 0.2. Okay, the probability of being cured by one of the 3 prescriptions is 0.08. And there I do it again, 0.88. I didn't even say it right the first time, 0.88. So you could just work that out. That's just a little bit of calculator work just to sort of solve that. Okay. So actually I will do that. Just pause my calculator for a second. So it is 0.2273 according to my calculator. Okay. So that's it all done. We leave it there. Great stuff. And you've got a free lesson in Irish and English vernacular. Okay.